Audio Jungle. Audio Jungle. Audio Jungle.
Hi, good afternoon everyone. My name is Michelle Baby, 21 years of age, and I live in Barangay San Manuel, Puerto Princesa City. And my favorite pastime is drawing, reading, and watching documentaries. And I just want you to introduce my family. This is my mother, my father, me, I'm the eldest, and then my sister, my brother, and my younger sister. And we love eating and hanging out together.
Audio Jungle. Audio
This
Jungle.
afternoon, we will be discussing about photodetectors and
Audio
light-dependent resistors. So here are our objectives for this afternoon. First, we will be defining photodetectors, identify its general process, identify the role of photodetectors and its characteristics, define light-dependent resistor, to know how light-dependent resistor works, define a spectral response, temperature dependency, and recovery rate of light detector resistor. We will be also identifying its characteristics, and lastly, we will be identifying the practical application of light-dependent resistor. Photodetectors are the semiconductor devices that can detect optical signals through electronic processes. So that means the extension of coherent and incoherent light sources into the far infrared region on one hand, and the ultraviolet region on the other hand, has enhanced the requirements for high-speed, sensitive photodetectors. So basically, there are three processes that a photodetector has. So one is carrier generation by the incident light, second is carrier transport and or multiplication by whatever current gain mechanism may be in present, and lastly the interaction of current with external circuit to give an output signal. So photodetectors plays a vital role in optical fiber communication system operated by a near-infrared region. So they modulate optical signals or convert the optical variation into electrical variations, so that are subsequently amplified and further processed for the application in strange requirement that are met by the photodetectors include the high-speed response, high sensitivity, at operating wavelengths and minimum noise. So the photodetectors must also be compact in size, use small biasing voltage current, and be reliable under operating conditions. So the best known device of these types are the light-dependent resistor, the photodiode, and phototransistors. So for this topic, we will be also discussing regarding the light-dependent resistor. Light-dependent resistor is made up from a cadmium sulfide containing no or very few free electrons when not illuminated. So its resistance is then quite high. When it absorbs light, electrons are liberated and the conductivity of the material increases. The approximate relationship between the resistance and illumination is resistance is equivalent to A times the E or illumination in lux raised to negative alpha. So the negative alpha or the alpha depends on the cadmium sulfide that is used and on the manufacturing process. So its value is ranging from 0.7 to 0.9, so are quite very common. So the relationship between the resistance and illuminations is also shown graphically. So as you can see in the figure, as the light intensity rises or increases, the resistance decreases. So that is the concept of light-dependent resistance. So as the light intensity increases, the resistance decreases. So this is the basic construction of light-dependent resistor. So the device consists of a pair of metal film contacts separated by a snake-like track of the cadmium sulfide. So there it is, as you can see. And it is designed to provide a maximum possible compact area with the two metals films. So the structure is housed in a clear plastic or resin case, so to provide free access to external light. Practical light detector resources are available in variety of sizes, package styles, and the most popular size having a face diameter of roughly 10 mm. So let us proceed to a spectral response. So the resistors are only light dependent over a limited range of wavelengths. So light detector resistors have their maximum response at about 680 nanometer. And also the temperature dependency, electrons can be excited not only by photons but also by thermal ignition. So the dark resistance is therefore not infinite normal temperature. So it increases also with the ambient temperature and can be reduced by cooling in the device. So the temperature also can affect the resistance under illumination at practical illumination levels and normal ambient. So the temperature of coefficient is however very small, and it can also be neglected. Next is we proceed to the recovery rate of light detector resistor. So when it is bought from a certain illuminating level into total darkness, the resistance does not increase immediately to the dark value. So the recovery rate specified in kilo ohms per second, and for current light detector types is more than 200 kilo ohms per second. So during the first 20 seconds, starting at the light level of 1000 lux. So that means the recovery rate is much greater in reverse direction. So going from the darkness to illumination level of 300 lux, it takes less than 10 millisecond to reach the resistance, which corresponds with the light level of 400 lux. So light detector resistors are sensitive because, as I have said earlier, or as I have discussed in our graph, as the light increases, the resistance also decreases. So you can see the difference between it. So it is also inexpensive because it is very affordable, I tell you, and it is readily available devices. And they are also good power and voltage handling capabilities, so it is similar to other conventional resistor. However, the only significant effects is that it is fairly low in acting, or taking tens or hundreds of milliseconds to respond to sudden changes in a light level. So the useful practical applications of light detective resistor includes the light and dark activated switches and alarms. It also includes the light beams alarms and reflective smoke alarms. So to further understand this topic, which is the light detector resistor, so let's watch this video.
May pakita ko sa inyo kung ano ba yung characteristics ng light dependent resistor or LDR. So from the word itself, itong light dependent resistor, ibig sabihin ng light dependent resistor, nakadepende sa amount of light na nag-hit sa kanya yung magiging resistance niya. So basically, meron tayong graph dito na resistance versus light intensity. So ito yung characteristic ng LDR. Habang tumataas yung light intensity na tumatama sa kanya, bumababa yung kanyang resistance. So resistance decreases with light intensity. So habang madilim naman yung lugar or less yung light na tumatama sa kanya, mataas yung resistance niya. Okay? So kapag kinonect natin siya, let's say dito sa isang circuit, simple LED circuit din, which is a 9-volt battery with a light-dependent resistor and then connected yung diode, pwede nating ma-vary yung intensity ng ilaw ng LED via the resistance nitong LDR. So kapag tinapatan natin ito ng mas mataas na intensity ng ilaw, therefore mababa yung resistance niya, mas maliwanag yung LED. At the same time, kapag diniliman naman natin or let's say hinawakan natin totally yung mismong LDR, tataas yung resistance, therefore bababa yung current na dadaloy dito sa circuit. So parang patay na itong LED. Okay, so try natin experiment kung mapapalabas ba natin yung ganong karakteristik ng LDR. Okay, so gamit tayo ng 9-volt battery uli, tsaka wire, tapos itong LED, tsaka itong LDR, tsaka syempre itong breadboard. So connect natin ito. So naturo ko naman sa inyo kung paano mag-connect ng components sa breadboard, diba? May video na ako doon. So kung hindi nyo pa napapanood, ay ililink ko na lang para ma-check nyo. So connect natin dito yung positive, tapos dito yung negative. Okay? Tapos, let's say ito yung LDR. So, walang polarity yung LDR, ha. So, let's say connect ko na direkta yung isang paa dito sa positive. Tapos, dito yung isang paa sa butas, kahit saan dito. So, medyo ilayo ko yung connection nitong LED dito sa LDR para pag inilawan natin, makikita natin yung difference. So, hahabaan ko lang, i-connect ko to dito sa mas malayo. Okay, so therefore, dito ko i-connect ngayon, itong anode, nung LED. So, yung mas maliit yon. So, dito. Tapos, yung cathode niya, dito, papunta na sa ground. So, ito yon. Dito ko kinonect. So, wire na lang ulit. So, wire papuntang ground. Okay, so, connect natin ngayon yung supply na 9V dito sa circuit. Okay, so nakita nyo, umilaw. So, ito pa lang yung ilaw ng surrounding. So, try natin kapag mas inilawan ko yung LDR. Meaning, magtatapat ako ng flashlight sa kanya. So, try kong magtapat ng mas maliwanag na ilaw dito sa LDR. Okay, so di ba mas tumataas yung intensity ng LED natin, yung ilaw ng LED natin, di ba? Kumpara sa wala. May ilaw, wala. So ibig sabihin, totoo yung characteristic ng LDR na kapag mataas yung light intensity sa kanya, mas mababa yung resistance kasi bababa rin yung current dito. So mas lalakas yung ilaw ng LED. Paano naman kung totally i-close ko ng daliri ko yung LDR. So, parang magiging madilim yung paligid ng LDR. Okay, so, di ba bumaba yung intensity ng LED. Ibig sabihin, tumaas na yung resistance ng LDR, kaya less current na yung dadaloy dito sa circuit. Okay? So, ito yung demonstration natin ng characteristics ng light-dependent resistor or LDR. Okay, so that's it for this video. So sana ay may natutunan kayo sa video na to at maraming salamat sa panonood.
Again, thank you so much for watching. Have a wonderful day. Stay safe and stay healthy. Bye-bye for now.